Okay, so good morning, everyone, and welcome to this first session about the basics of HPC and mainly Linux. So this is, as Alfonso said, this is the first time that we are doing this winter school virtually. So it will be a first time for me too. So please be indulgent. So the teachers for this session are myself, Okba, and Carlos, who is in the audience. So if you have questions, do not hesitate to use the either the chat by asking just your questions, and we'll do our best to answer you. So as Alfonso said, the session is 4 hours long, so it is pretty long. So I will take every hour we'll try to have a 10-minute break in order to everyone to have a coffee or have a break. Please keep your microphone on mute so it is more comfortable for everyone to avoid the background noise. And if you have any question or concern, please raise your hand. I will leave you a few seconds to get to know Zoom if you are not comfortable with it. So please take a look at all the buttons that you have. In the reaction, you have a button called reaction. If you click on it, you will see that you have a couple of clicks you can do. You can either raise your hand, you can share an OK emoticon or something like that. So during the session, I might ask you some questions where you can answer by yes or no. You can use these answers in the reaction button. And a couple of one more comment. The most important thing is that this session is mainly designed for beginners in Linux and HPC. So if you are kind of an expert on Linux, I apologize in advance because it is our experience show that it is mainly useful for med students who start with Linux and HPC. So we'll try to do our best for them to get let's say to get very at ease on Linux and HPC, and we will show them how to connect to the cluster and how to navigate within it. And starting from now, we can start the the course. Maybe a couple of words about me. My name is Okba, as I said earlier, and I work for a company called Atos. And this company is a digital company which has a division for HPC. And we are specialized in many technologies, which we can divide either by field technologies or profile. So we have a bunch of experts who work on GPUs and or CPUs and on even some on different fields. Weather forecast, seismic, fluid dynamics, chemistry, etc. Carlos is here is here with me, but he works at Surf Sarah. Carlos, do you want to take the time to say a few words about yourself?
Well, let me just connect the screen a moment. I don't know if it is possible. So, but yeah. Hello everyone. My name is Carlos Teixeiro Barcias. I am working at Surf right now, who used to be also Surf Sarah. It's the supercomputing center of Amsterdam in the Netherlands, and we are like the national compute facility for Dutch researchers, but also a member of the community of supercomputing centers in Europe. Just like the BSc and other centers in different countries. And well, we are working in providing support mostly for researchers in the Netherlands, as I commented, but also in Europe in general. We are participating in different projects like this one, Compiomed, or Praise, or other collaboration with other supercomputing centers and institutions in the Netherlands. And well, that's from my side. Thank you. I will be helping in this course also.
Thanks, Carlos. Okay, so let's jump to the start. So we'll start this first session with some basic comments on Linux and also one more comment. So during the session, there will be some labs, and I will ask you to, like, for example, for this first session, what we'll do is get to know the command line, because if you want to work on a supercomputer, you do not have a graphical interface such as Microsoft Windows or maybe your Mac. So you will need to get used to the command line and to be able to talk to a supercomputer. So this is what we will study this morning. So we will see about the command line, some basic for the navigation. We'll see how to handle files in the command line, and we'll see how to edit a text file, for example, and some other important points. But the first item of the agenda is how to connect to the cluster. So I guess you all received a username and a password. If you did not receive one, then something is wrong. Maybe you can comment on the discussion panel and say that you do not have any logins. And we'll try with Carlos and Alfonso to solve this problem. One of the requirements for you was to install either a mobile Xterm if you are on Windows, or if you are on Mac or Ubuntu, you don't need so. You just need to open a terminal and get connected to the cluster. So you just need to type in the command SSH, the username that you received from BSC. It should have the form of NCT, NCT00 and some other ciphers. So whenever you're ready, do not hesitate to raise your hand using the button that I have discussed earlier.
Hello, good morning.
Yes, good morning.
Good morning. Just a very quick question. So these usernames should be NCT01 and then the specific.
It depends what you have received. You should have received an email with your username, and I'm pretty sure they all begin with NCT. And then depending of the number of participants, maybe they have different numbers afterwards, but it should start with NCT 0 something. So
I see.
If you are over 100 or over 1,000, I don't know. Maybe they are generated randomly, so they don't respect the 00 and then the digits. So, but they should start with NCT.
And this actually SSH, I have seen it many times. Is this stand? I don't know. Is it a special word or this SSH?
It stands for a secure. It's a good question actually, because I've never tried to look for the meaning
Maybe
of
not
the letters.
very important, but I was just curious. I have seen it a lot.
Yeah. So it is what it means. I don't know exactly then what for the it's secure shell. So it means that you're establishing a secure connection between your local computer and a distant computer, and that's basically the meaning of SSH.
Thank you.
I was about to comment that it's actually secure shell, I think.
Yeah.
It's just as simple as that.
So please do not hesitate to either raise your hand or maybe click on the OK button once you have succeeded to connect to the cluster. So this way, I'm looking at the participant panel, and this way I can see if everyone was able to do so or not, because it is important that you all succeed to connect to the cluster in order to continue. So please take the time to do so. And if you have some trouble, do not hesitate to
Hello.
either ask a question or maybe just a comment verbally. Hi, yeah.
Hi, so I'm having a issue with the password because I can enter the username, but when I enter the password, it is saying that it's not correct.
This, well, from that point, I cannot help. Just try to. How many times have you tried? Did you pay attention to the numbers or the
yes,
catch?
because the number is
Yeah.
my number is means in the table, so it's fine. But when I enter it there, maybe I'm having some issue with the text over there, because the password here is something like 5p5jnq dot and the number. But when I put that number, it's not entering. I
Yeah.
don't know.
Okay. Maybe Alonso, are you in the audience? Alfonso, sorry.
Alfonso maybe is not there, but I can help a bit with this if you wish. It's not a problem. So in the sense of the password, one of the most typical problems is that you copy it from the let's say from
email
text into the terminal. This is a bit complicated sometimes, because when you think that this is copied, then depending on the terminal emulator, then the password doesn't show. So it's not clear if it is actually introduced or not. And
so can I type my password here so that I can show you, or no?
Yes, I mean, it's. I think it's possible. Then the thing is that it's better to type it character by character rather than, for example, copy pasting it.
So Carlos, I am texting you right now just for you, so to let me know if it is correct.
Okay. Yes. Please.
Yeah. Also, I got a message could not resolve host name.
Yeah.
mn1.bs.
I believe you have typed wrongly the address of the cluster. It is mn1.bsc.es. So make sure you type correctly the address.
I see.
Yeah,
I see.
.es. Yeah.
It says the authenticity of host mn1bsces cannot be established.
Yes, at this point you can simply say yes, because this is a thing that happens when you are connecting to a system that is not known to you, and you just simply say yes, and from that point on you can connect to the system and it will be known to your machine.
I see. So we should put yes, like giving permissions, something
Exactly,
this to
yes. And you're not selling your soul to anybody or having any trouble, don't worry. This is just that the system will know that this mn1.bsc.s is a known IP somehow, and it's trusted.
I see. This mn1bsces is like address of the supercomputer of your side, something like that.
Yeah, so to say.
Yeah.
Hi, Mohammed. Are you able to to connect to the cluster, or do you still have some trouble? Yeah, so don't use the bracket. So just
kind of confusing because you put a bracket there, so I don't know whether I should put it there or not. I mean, that's
no.
If you want to just
No.
some X's, so I would understand that I could change the numbers. But that bracket, I put it there, and then my mobile extreme kind of, I don't know, getting crazy.
No, please don't use the bracket. Only use the NCT and then the ciphers. And for the password, it should be only letters and ciphers.
Oh, okay, cool. Thank you.
Yeah.
Maybe
So
another question.
Is there anyone else we may assist with the cluster connection?
I think just when I put passport, it says connection closed by some number port, for example, I don't know, 22. That means this is completed, yeah, when it says connection closed.
No, this is actually one of the problems that can happen. When there are when you get the connection, you actually get a splash message that is showing well, welcome to Mare Nostrum, and so it's let's say something that you really realize that you are in. When you are in, you can easily see this immediately. The point is, when you see this type of message, it can happen that you are temporarily blocked from connecting to one of the login nodes. Don't worry about that. This is not something tragical, and there are several solutions to this.
Okay.
A cluster somehow has different nodes to which you can connect. And in this case, we are using mn1.bsc.es, but it is possible to use, for example, mn2.bsc.es or mn3.bsc.es. You can use alternatively one of those. And if you try with, for example, mn2 right now, maybe you get in. It's something that can happen because of many failed connections, so to say. If you have tried to type the password once and failed twice, then this happens. And one solution that you can do also to solve this is either choose a different login node, which is instead of mn1, then mn2 or mn3, or alternatively, you can use a different IP address for your internet connection. That means, for example, if you are at home, you can connect to the VPN of your institution. If you are connected to the VPN from your institution already, you can go out of the VPN and try to connect directly. Or I believe it may be also possible to connect if you use a mobile hotspot. I am understanding that the system will be reachable in these three cases. So just please try, if anybody has having problems, please try a different login node instead of mn1, maybe mn2 or mn3, and alternatively try a different IP address. That should solve everything.
So if you're able to see my screen, I use MobiXterm, and this is basically how you start a new session. So you either do new session, or maybe if you already created one, you edit it, and this is what you should have. These only two information. It is the address of the host. It's either mn1, or as Carlos say, you can put 2 or 3 instead of 1. So here, 2 or 3, and then enter your username here in the area, and then once it's done, you just double click. So fortunately, as I have already logged in the cluster, I don't have to type in my password because I saved it. But if it was the first time, I would have to enter my password manually. And once you are on the cluster, this is what you should see. So you should have a black screen with a message in it, the welcome message of Mare Nostrum 4.
Actually, I got a special message. I will copy and paste it somewhere. Maybe you can, if you don't mind.
Yeah, sure. You can put it in the discussion table.
So it's like...
Are you sure you're not forgetting some zeros in your username?
Oh, I see, I see. You mean when I wanted to connect, I see. Okay, okay.
Check carefully your email with the username. It should have many zeros.
Yeah, you're right, you're right.
Not many, but it should have at least 5 ciphers.
Hello, Ogba.
Yeah.
So I am using a Mac right now, so I don't know why I can't enter. Means what should I do? Because I showed to.
If you're using Mac, it is even simpler. Just open a terminal. So if you open a terminal like this, you should have this kind of interface on your Mac. You should have a command line.
It's a terminus, right?
Terminal.
I didn't catch that. Could you try again?
So just list your apps on your Mac and just type in terminal on your search area, and you should have the terminal application.
Yes, terminal is there. Yes, now.
Yes, and once you open it, you just need to do SSH, your username, I mean NCT something, at MN1 or MN2 or MN3, maybe try MN3, for example, at bsc.es, and then just enter NCT.
Yes. So it's saying not found.
It's weird because it means either you don't have an internet connection from your terminal or...
No, I am having internet connection here.
So it should ask for your password afterwards like this.
So I'll put MN1 then, because I think that will...
So I think my case, in the command prompt, it appeared. It's Mare Nostrum 4.
Yeah. Okay. So perfect. So you're ready. You just need to wait for the other participants to.
Okay. That's great.
Adjust.
Thank you.
Yeah, no problem.
Seems happy. Just you mentioned about a company called Atos. This is a company in Barcelona, separate from the supercomputing center.
Yeah. This is a private company separated from BSC. It is an international company which does a digital transformation, and they have an HPC division. So
I see.
Myself, I'm based in France.
So excuse me. Ogba, I need to add just the NCT number and that's it.
Yeah, you do SSH, your username, so SCT, and then the figures, the numbers, and then at MN1.
SSH, after that you should give a space or not?
Yeah, a space. Yeah, of course, a space.
Okay, and then number, my number NCT01 number, then at the rate.
Can you see my screen?
Yes.
So can you see the command that I have typed, SSH, and then space, and then the username?
Yes.
And then there is the @ character.
Yes.
And then MN1.BSC .es.
Yes, same thing.
Okay. So when you hit enter, what does it say?
It says that the authenticity of MN1 can't be established.
So try the same thing, but with MN2. Instead of 1, type the cipher 2.
Yes, so now I put it. Now it's saying the same thing. The authenticity can't be established.
Sorry, would you mind putting in the chat maybe the exact message as a private message to me?
1 minute. I will...
Just to check the.
Yes, yes.
Yes.
So yeah, I send you the 2 messages which I received.
Oh yes, and this is the one that indicates the the privacy. Just please say yes. You should say yes over there. You should continue connecting.
Ah, okay.
Because this is what we commented earlier, that there is a problem in the only problem is that your connection is not recognized. It's a new system to your computer, and then it doesn't know what is happening.
So I should pray that continue connecting, yes.
Yes, and then you trust the connection. That's the thing.
Okay, so now I have to password and that's it.
Yes.
Yep.
Okay, thank you, Carlos. But actually the passport is not typing. It is showing some symbol here.
Yeah, it doesn't show anything when you type the password. So just make sure you type in the characters and you hit enter.
Okay.
Yeah, don't worry. It is mainly due to privacy. So if someone is watching your screen, they don't know if you're typing something or not.
Yes.
One question, these usernames, password you provided to us, for example, today afternoon or after the course, can we use or are we permitted to use this connection to practice or something? Or is it just this week, so to speak?
They should be valid for the whole training session, so until Friday, I think. Okay. And afterwards, I don't know. Maybe we should ask Alfonso or maybe the BSc support team if how long they remain active, these accounts.
And maybe
so they are mainly issued for the training session.
And maybe just one general question. Let's say if sometimes there are big projects and our computer is really not to the level supporting the calculations, and some supercomputer centers, they like sell or kind of like hourly, or I don't know, per CPU, per core, provide some possibility to have access or connect there to remotely, let's say, run some simulations about fire dynamics and so on. Does the Barcelona Supercomputing Center offers these type of services?
I'm pretty sure yes. Maybe you need to get in touch with the support team, or maybe get on the BSc website and try to reach out to them and see how you can do that. But I'm pretty sure you can buy some compute hours on the on the cluster.
Okay, okay. Thank you. Thank you. Gracias.
So is everyone able to get on the cluster? So if you did not, please say so, and we will try to get you on the cluster.
Yes, I could do.
Okay, so has everyone did not succeed? It is important that everyone is online on the cluster now. Okay, so I guess everyone has succeeded.
Maybe it's
So,
possible to just give it with a yes or a no in the if you go to the participants list,
yeah,
just to know that everything is correct.
so we are 32 participants. We should have around 30 answers.
Yes, and we want them all if possible.
Yeah.
Because actually it is important to say no at the right time so that we know that there is a problem, and we would like to see everybody. If you are not answering,
And
then you are sleeping.
unfortunately, there is only 3 people who answered.
Yes. Well, then I am seeing 12 people. Opa, I think you are seeing also 12 people, I guess. Could you please press the yes button? Here I am pressing now the yes button. We would like to see your yes button. The only one exempt from pressing the yes button is the education and training host from BSc, but the rest, everybody should press the yes button. Please press the yes button.
Do not type yes, but
no.
Press the yes button. You have a reaction panel. If you click on the reaction button on Zoom, you'll have a you will have a yes answer. You just need to click it.
So sorry, we could see this Mare Nostrum 4 in the command line, and we should stop there until further instructions. I don't know if you could hear me.
No, so sorry. We were having some trouble hearing you. Can you repeat?
Yeah, sure. So actually, we are on the command prompt, and we see Mare Nostrum 4, and there is blinking. I mean, our username at login 1, and we are there blinking. Should we do something further? Or?
Yeah, it is normal. It is normal. It means that it is waiting for your instructions to do something.
Yeah. And should we do something
so just
more?
stay there and wait for the course to continue.
Okay. Yeah, just wanted to make sure if I didn't lose any part. So we just wait at this point. Okay. Thank you. Sorry if some questions looks primitive, just to make sure we are not missing any steps.
No problem. I know that some of you are really beginners, so it is important that everyone follow the whole course, because later on during the training, you will have, well, they won't take so much time explaining how to connect to Mare Nostrum. They will focus on the most important things on the, the medical, computational medical training. So you will need to be already, let's say, ready to connect and to launch job, etc.
So we will simulate some cases with you. That's great. So Mare Nostrum is the name of a supercomputing in Barcelona, supercomputing center, if I understand right.
Yes. It is the name of the, not the, yeah, it is the name of the center, yeah. Or maybe the, it is the name of the cluster actually.
Cluster.
Each cluster has a name.
I
So
see.
the computing center may have several supercomputers. So the name of the supercomputer you're using is Mare Nostrum 4.
Okay.
So for the yes and no question, if it is easier to raise hands on Zoom, please do so. So, okay, I got 2, 3. Please use the command so we can know if you can go forward or not. 6, 7, 9, 10. Okay, it's going up. That's good. Hamid, please use the raise hand and do not type yes as a text message. Keep it raised, please, the hand, until I get to the stable number. Okay, so it is stable at 21, 22. So it means there's at least 8 people who are not able to connect to the system. 7 people, actually. So please, if you're having trouble, can you please ask for help? We are here to help. So don't hesitate, don't be shy. There is no silly question.
Hand, is it in, I was looking for.
Okay, so there is, okay, Carlos, you're not concerned. Amor, Dizay. Okay, it's good. Daniel Romero.
Hi, yes.
Yeah, you can unmute and speak if you want. There's no problem. Are you able to connect to the cluster?
Yes, but I use the terminal for Windows. I didn't use putty or mobile Xterm. I could enter using the terminal from Windows.
Did you use PowerShell? Is that what you're saying?
The command.
The command line?
Yes. The console from Windows, the original command Windows. I open it and enter with my account that you sent me, the email, and it's okay. I have the same screen that you with Mare Nostrum, etc.
All right, but for the hands-on, I'm afraid you won't be able to do all the labs because at some point you will have to use some other commands called SCP, and I'm not sure that the Windows terminal will be able to handle that.
Okay,
so,
well, anyway,
were you able to install putty or
yes, for sure.
Yeah.
Okay,
so,
I will try.
Can you switch to mobile Xterm or something like that?
To putty maybe.
Or putty, yeah.
Okay.
So yeah, I see that. Okay, Amid. Okay, so I guess we are full now. We can continue. Thanks, Carlos. Okay, so the next step is to understand what we are saying. So what you have in front of you and what you have actually, I will show you also sometime the, okay, I will take this. Hop. I will have the small terminal here. So what you have in front of you is called the terminal or the command line interface. And what it shows to you is actually, it is blinking. So it is actually waiting for you to ask stuff, to do stuff. So if you want, you can type in a first command, and the first and easiest command is ls. So if you type ls, and this is what I'm showing here in the slides, it has several aliases. So you can type L, LS, LL, double L, etc. And what it shows is that it will show you what you have in the current directory. So as you are new users, you may not have many stuff. You have probably new environment, a new home, so it should be empty. So if you type ls, you would have a list of items. So myself, when I type ls, I have this kind of output. I have 3 directories called bin, labs, and my dear for my directory. I can type some other commands. For example, ls comes with options. For example, ls-a. I can see also some other hidden files, for example. I can type other commands called pwd. It can show me the location that I am in. So it shows that I am, well, my home directory is called nct 404. And it shows me also the location where I am. So I am in the directory home and also in the subdirectory nct00. So this is how we interact with the command line. So if you type enter, it doesn't do anything. So it doesn't react. It reacts only when you type a command. So enter is used to validate a command. So, okay. Moving forward. So one other basic command besides ls, which tells you what you have in your current directory. There is also the command pwd. Pwd means print working directory. It shows you actually where you are located. So as you see, the same thing as on Windows or Mac. When you open a file explorer, or a file explorer, you can navigate through your directories, and you can do the same thing in Linux, but not using the mouse, but using the command line. So when I do ls, I can go inside labs, and I can see there are other things. I can go also inside subdirectories. And if I want to know where I am, I can type the command pwd. And it will tell me that I am in lab 3, which is under labs, which is under NCT 004, etc. One other important command is, as I said earlier, is ls, which tells you what you have. It lists the content of the directory. So you can use ls without any options, and it will give you only the names, as it is shown here on the left. As it is shown here on the left, and you can use it with some options. So when you type ls and then space, and then you do dash, some options, for example, lrt, it will display you the content of the directory, but with more information. So T will show you the time that you have lastly edited the file, for example. L will do a sorting, and not the sorting, but it will display the information about the users and the group. And R is used for a special sorting. So you can do this exercise in your own terminal. So you can go ahead and explore your home directory. So I don't know if you have any files or something like that. I think you should have a bin directory. Yeah, and it should be empty. So you can do that at least, or even in your home. So you just type in CD and then nothing afterwards, and you hit enter, and it should take you to the home directory. And inside your home directory, you just type in ls-a, and you will see what you have in your current directory. So try to type in ls-a, and then afterward just ls, and see the kind of output you have. ls-l.
Sorry, what is ls-l?
So ls-l is, so the -l is the option for, is an option for ls. So it means that you want to display more information about the content of your directory. So for example, if you're looking at my screen, if I type ls, you only see the names of the items I have here. So I have basically 3 directories. If I type ls-l, it will provide me more information about these items. So for example, it will tell me that they are directories. It is it is the meaning of the first letter actually. D is for directory. Okay. And then it will give me more information about permissions and ownership. But we will come to that in details later. And this is the content of these letters here, the R, W, and X. And then it will tell me who is the owner of these directories and to which group it belongs. And it may give me also the size of the directory. And finally, it will give me the date that it have been lastly modified. So yeah, so some of you will see only a bin directory, and it is normal because it is the first time that you are opening your accounts and it is empty. So the bin directory is created by default. Okay, so we will start creating things now, and you will see that things will be moving. Okay, so going forward. So as I said, it is important to know where you are when you're using the Linux command line. And there are two, let's say, there are some shortcuts that are important to know. The first one is pwd. It is a command line to tell you where you are actually. So it will give you the path to your current location. So for example, if I move in the system to GPFS project NCT 00. So see, I have moved my location from my home directory to another directory. And if I type here, I can see a bunch of directories here. And if I want to know where I am, if I want, for example, to copy stuff to this current location, I can get this location by typing pwd. And this will give me a path to this current location. And I can use this path in my script or in my command line to copy stuff, for example. And the other thing is that you have also some shortcuts, and these shortcuts are mainly listed here. So you have the tilde character. It is a shortcut for your home directory. So if you type in if, for example, I want to go back to my home directory, I can type in cd and then the tilde character. And if I hit enter, I will go back to my home directory, which is this one here. So it is home/nct00/nct0404. So try practicing these basic commands to see how it is going on. One other shortcut is the dot, and the dot basically refers to your current directory. So, for example, if I want to move from my current directory to another directory, I can go back from the current directory and then go back up, for example. And this is actually the meaning of the double dot. Double dot means the parent directory. So for example, if you go into bin directory, if I do cd bin, so I am actually in the bin directory. Okay. And if I want to go back to my parent directory, I have to type in cd. Cd stands for change directory. Cd ... and then I go back to my parent directory. And here you see that you have a tilde here. So it is small, so you have to focus to see it. And it says basically that you are in the home directory. Okay, so moving on. So I have showed you how you can see where you are using the command print the working directory, pwd. You can change the directories by moving using cd, and cd is, I already said that, but I repeat, it stands for change directory, and it will allow you to move from one directory to another. And this is how you will be able to navigate through a Linux file system. So basically, when I do ls and I have directories, so I can move into a directory by doing cd space bin. So if some of you have trouble with the tilde character, so the way to type in a tilde character is to hit the button which is at the right of the space bar. It says Alt-GR. So you keep pressing Alt-GR, and then the tilde should be on the same button as the number 2 upper to the Z letter. I mean, it depends what kind of keyboard you have, but it should be around there. So if you press Alt-GR and then you hit two times, it should give you the tilde character. Otherwise, you have to look for it on your keyboard. If you have questions, do not hesitate to ask them on the discussion panel. We will take the time to answer you. And one other useful thing to know about Linux is when you type commands, the system is smart enough to guess the command that you want to type. And how to make him guess is by using the tab keyboard touch. So when you start typing a command, you can use the tab, and it is useful to it will help you to autocomplete the command that you want to type. So for example, when I do ls and I want to go into the labs directory, so I will do cd, and then I will start by typing the L character, and then I hit tab. And it will automatically guess that I want to go in the labs directory. So I don't have to type in the whole name of the directory. I only have to start with the first letters, and then I hit tab, it will complete the name overall. So this is a good shortcut to know. So the tab thing can help you with the commands and also the file names and also the path. So for example, if I want to move into a special directory, for example, I want to go change cd, and then I go into the root, and then I start typing gp. Instead of typing, because I know that it is called gpfs, I can type gpfs and then slash. But if I don't want to type the whole thing, I can do tab, and it will do it for me. So gpfs, and then if I do tab, it will just to me that where I can go. I can go into projects. So I start by typing PRO, for example, and I hit tab, and it will automatically complete. So I don't have to type the whole project's name. Okay, and then I go enter, and everything is good. Okay, so these are small examples of how it can be easy to navigate through a file system in Linux. Okay, and one last thing is about a file, about the files in general in Linux. So I guess you are all used to Windows and Mac, and the graphical interface. So it is convenient. So if you want to open a directory, you only have to double click, for example. Or if you want to open an image, so you only have to double click, and Windows or Mac will automatically launch you, I don't know, your image reader. Of if you click on a PDF file, it will open for you Adobe Reader, for example. So in Linux, it is you need to know what you are doing. So the system doesn't guess for you what you want to do. So you need to be precise of what you want to do. So on Linux, you need to know that everything can be is a file actually. So and the extension that you want to add afterwards, it's only relevant to you. So if you want to create a file that is a text file, for example, let's call it file example.txt. So the .txt here is only relevant to me because I want to recognize it to be as a text file when I look at it. So I can easily do not give it any extension, and it will be a text file here. Okay. When I do ls, I will see here that I have a file example, but I won't know if it is either a text file or an image or a PDF file or an Excel file, whatever. So when you create files, you need to be careful, but for you, in order to know what kind of file it is. So you can add an extension to your file. So if you want it to be a text file, you can add, for example, a txt extension. If you want to make it as a data table, you can add a CSV extension to it. If you want to open it with Excel, for example, later on, If it is an image that you are computing, for example, and storing, you need to add a JPEG, for example, extension. So once you transfer it to your Windows or something, you will be able to open it easily. And one useful command is to use the file command. So the file command will tell you what kind of file you are having. So if I type in file and the directory bin, it will tell me that bin is a directory. So this is what I'm showing on my terminal. And if I
just maybe one question,
yeah,
if you don't mind. I think when you, for example, what I typed, I tried to type this file thing, and then I got a message called dash dash replace dash dash. I'm not sure why it happened.
I'm not sure what you are doing.
It looked like everything went like the whole terminal became black, and then it showed dash dash replace.
What command did you type in?
I think I put this command just file without txt. When you were making, you wanted to show how to make.
You did touch. You did this command. Can you type it on the discussion panel?
I think I just typed file basically, or file bin or something like that.
No, it should give you an answer like this.
I mean, maybe I can copy it. It's kind of like I used Linux before, but I have never seen this. So it looks like it's kind of like the whole thing is black now. It says.
Yeah, I think you are stuck in VI in the text editor.
I put VI.
What you need to do is type hit several 2 or 3 times the escape button.
I see.
And then you need to do, once you have hit the escape button 2 or 3 times, you need to hit the colon button.
You mean the column?
Column, yeah. The 2-1 on top of the other, and then WQ in order to exit.
Oh, dash 2 times. I see. 2 times, and then WQ.
Yeah.
It says press enter or type command to continue. It says no previous regular expression. I put dash dash WQ.
Not dash-1 after the other. Can you see the discussion panel? I have just sent the characters you need to type. Yeah.
I see. Dot WQ. I see.
And you should be able to exit this editing mode in VI.
So basically, for going out, it's like 2 times escape, and then yeah.
Yeah, I will give you more details on how to use VI a bit later on. Because if you're not used to it, it will be a kind of pain to use it. Okay, so moving forward, one important thing is about the spaces in the names. It is important to know that Linux doesn't like very much the spaces in the names. You can do spaces in the names, but you will have some trouble managing them later. If you want to copy them or move them or delete them, you will have to enter special characters. So what you can do, for example, is try to create a file with a space in it. So actually, this typically happens when you copy something from your personal computer, from Windows or Mac, where you always have spaces in the names, and you move them into the cluster. So you keep these spaces in your names, and then later when you try to work with them on Linux, you will have some trouble. So what I will ask you to do is, I will ask you to try to create new files, and this is basically, you can do that with the command touch, T-U-C-H. So you do touch, and then you hit the apostrophe character, and then you do file example. You can name it however you want, and then you give it an extension for a text file, for example, and then you close with the apostrophe. And then once you hit enter, you can type in ls, and you will see the content of your directory, and you will see that you have a new file called, well, the same way that you have created it. And it has a space in it. And we will see that it will be difficult to manage this kind of files, and we will see how to circumvent this kind of issues.
Just one question. These videos are recorded, yeah? We can watch later also.
Yeah, this is what I said earlier. I don't know if it is recorded for this purpose or for some other purpose, but we can ask the BSc support if they make these videos available or not.
I see.
So yeah, we can keep this in mind for later.
Just one question. This touch, so by using touch, we can make a file. This TO.
Yeah, you create an empty file.
I see, empty file. But does it specify the type of file also? Like text file or exe file?
It is empty file. It can be it depends what you want to put in it.
I see.
But yeah, it's mainly characters.
I see. Actually,
so
I got
has
some
everyone
message.
succeeded to create a file with a space in the file name?
Actually, I couldn't make this because I got this error message I sent you. So I don't know why this happens. I think it's still in VI.
I think you are still in VI. So have you pressed the escape button?
Yeah.
And then you type the two dashes with the Q or the WQ, and then hit enter. You should be able to get out from there.
When I put WQ, it doesn't work, but I can put Q if you want.
Do WQ and then the exclamation character afterwards. It will force the action.
Ah, WQ
just like Jorge suggested in the discussion panel. So have you succeeded, Amid?
Yeah. I think now it works. Yeah, thank you.
Okay, so if you create a file just like I did with touch file example.txt, you should have a text. You should have a file with a space in it, and we will see how to manage this kind of files. So if, for example, you want to ask what kind of file it is, so I showed you the command earlier. So you type in file and then space, and then you ask for the for the file you want. So if it is bin, it will tell you that it is a directory. But if you want to ask for the file example that you have just created, so if you do file and then file example, well, you will see that you have a special character that has been inserted. But if you type in the, for example, if you select the file in question and then you insert it, you copy paste, you will see that you will have an issue. You will have a problem. The command line will tell you that, well, the file doesn't exist and example doesn't exist. And this is because of the space that is inserted in the file name. So Linux interpret it as two separate files, actually. So this is why I told you that the Linux file system doesn't like very much spaces in the file names. So we will have to avoid that. So in order to use it correctly, we will have to use either the the apostrophes embracing the whole the whole file name, or you can use the backslash inside just before the space. So for example, if I want to do this correctly, so I will have to do file and then file backslash before the space, and then I hit the space and then example.txt, and it will tell me that file example is an empty file. So you need to be able to succeed this kind of operation. Okay. And the last thing is about the hidden files. So in Linux, if you want to hide files, you simply need to put a dot as the first character of the file name. So in Windows or Mac, you just need to, click on the file or click in the display preferences and then, show hidden file or maybe hide files, etc. In Linux, it is easier because here I can create hidden files simply by doing a dot before the file name and then my secret file .txt, and then I won't be able to see it in my directory. And the way to see the hidden files in the directory is to use ls with the -a option. And when I type in this command, I will see that there are a lot more hidden files, and these files are mainly used by the system. For example, the bash history, the bash rc, the -cache, -config, etc. And I will be able to find my secret file somewhere in the list, and it is right here.
Just maybe one question. I sent a short message in the chat room. I was wondering before.
Which question?
Actually, I wrote nct login 1 and so I mean.
Can you repeat?
So sometimes there is a tilde.
Yeah, the tilde means that you are in your home directory.
But sometimes
it means that,
yeah, instead of tilde, we have a slash instead of tilde. So I don't know.
Well, slash means that you are in the root directory. So if I type in cd /, it means that I am in the root directory, and this is where all the the system is located, the root of all directories. It's like if you're using Microsoft, it means that you are in the C directory. Okay, so in the C // it means that you have all the program files, Windows, etc. You are not in your, in the desktop where you have all your personal files.
But
so the easiest way to go back to your home directory is only to type CD and then space, and you just need enter, and you will go back to your tilde directory.
I see.
Okay.
Thank you very much.
And you should not write stuff in the slash directory. It is I mean, first, you don't have the permissions. It will give you some errors, but don't try. Okay, so let's keep going. We will see how we can create directories. We have seen that how we can create files using the touch command, touch my file -txt. Okay, and we'll see how to create a directory. And the command to do that is mkdir. Mkdir stands for make directory. So you type in the command mkdir and then space, and then the name of the directory you want to create, and then you hit enter. And if you type ls, you will see that you will have your new directory, which appears in the list. Okay, so you can try that. So I can do mkdir. Let's call it work dir 1, for example. And you see how I am inserting a dashes in the names. If I want to separate and make it more clear for me to read, I don't attach everything and I don't put spaces, because it will make life not easy afterwards. So when I do ls, and I will see later that I will have the directory I have just created here, and I can go within this directory. So I can type cd work, and then I can hit the tab keyboard touch, and then it will complete automatically. And I can do enter, and I will be inside this directory. So this will be useful to create new directories in order to, organize work and not having all your files in the same directory for everything. Okay, and you can do one more thing with the make directory command. It has some nice option to create, you can create directories and subdirectories at the same time. So you only need to specify the option mkdir-p, and I want to create directory 1 and subdirectory 1 and sub directory 1. And if I hit enter, I will see that I have directory 1. And if I go into directory 1, I will have subdirectory 1. And if I go into subdirectory 1, I will see that I will have subdirectory 1. So I am able to create a whole, architecture of, arborescence of a subtree of directories, one below the other, just from one command line. I don't have to repeat the same command, directory by directories. Okay. And if I do pwd, I will see that where my current location is. And it is in the subdirectory. So I can go back to the parent directory with using the cd space ... So I go back to, I don't know if you can see clearly here. So I moved from subdir to dir1, okay? And I can do the same thing using the same command, and I go back one step above. And I can do actually the whole operation in only one command. So I can do cd // etc. I can combine these two commands at the same time, and then go back directly to the parent directory. Okay, I hope everything is able to perform these basic commands. It is important that you do so, because later in the training, I don't think you will have the time to ask questions about how to create a directory. So make sure you're able to perform these basic operations now in order to be comfortable with them.
Just one question. If something happens or we put something wrong, what is the best way? So maybe we type something wrong. Should we use escape button 2 times or to go to home directory? I'm not sure actually.
When you say something wrong, what kind of wrong do you mean?
So for example,
if you have if you made a mistake in the name of the directory.
Yeah, when we are making it, or
for example, let's say if you are looking at my terminal, let's say that, okay, I have dir1 here and I want to move into this directory, but oops, I made a mistake. I typed 2 instead of 1.
Yeah.
So you will just have an error saying that, okay, this file doesn't exist. So repeat, but correctly.
Okay.
Okay.
So mainly what you were meaning is that when we use touch, we should use touch and myfile.txt. This is just an empty file. And then
it is an empty file,
yeah. So it does not.
We'll see, for example, if you have created, a file with the wrong name, we will see how to change these names easily. So you don't have to worry about that. But there is only one command that is not reversible, and it is the deleting command. So if you delete something, you need to know that in Linux, there is no trash folder where you can retrieve your things. Once it is deleted, it is deleted.
Okay. What is the delete command? Is it del or?
No. It is rm.
Rm.
So, for example, if I want to delete this directory, I will have to type in rm. Since it is a directory, I have to specify that it is a directory using the -r option. And then I type in here, and it is deleted. So if I type in ls, it will show that it is empty, and there is actually no way to retrieve this directory and its content.
So -r indicates this is a directory.
Yeah. Okay, so if we move on. So I showed you how to create an empty file, for example. So we can move on with that. Now I will show you how to copy your files from one location to another, or mainly for, saving purposes or versioning purposes. So let's say that you have a set of data that is stored in your file.txt here, for example, and you want to copy them into another location, or you want to copy them in order to save them. For example, let's say I want to save them and call the new file, saved, etc. So the command line is cp for copy. Okay, and you specify the file you want to copy. Okay, and then you specify the name of the new file that, you know, the new file that you want to create. So it will be my file. And then you need to change its name, of course, because you can't create two copies of the same file. So let's say save, for example. So if I type enter, I will have, you know, the new file that is created, and it will be the same, the exact same copy of the original file. I can do the same thing. I can copy the file, but into another location. So if you see here, I have copied this file into the same directory. So I can do the same thing, but copy it inside another directory. So I can do that using, you know, the same command line, my file, .txt, and then I want to copy it inside this directory. So I can do this. So either I keep the same name. So in that case, I don't have to specify a new file name. So I can only hit enter. And if I do ls into workdir1, I will see that I have the file into this new directory. Or maybe I can change its name. So if I do 2 arrows, I have access to the history of the commands. So I do cp, my file, workdir, and then I can specify a new file name, new file.txt. Okay, and then I hit enter, and I will see that in the work directory, I will have a new file, which is the copy of my file. Okay.
Just wanted to ask, this topic you mentioned, is it important for later today? This last 1 minute.
Yeah, it is. It is pretty. It is pretty important to know how to copy your files.
Because
once you have,
I was like doing trying something, but I left behind, so maybe I lost what you were saying.
No, te troviamo di meno di
Very
50 euro
sorry
il
about
pappone, 60 euro, scusa.
yeah, I mean, you need to be able to know how to copy your files.
So basically, it's just cp
Yeah,
dash
the command line. The command line is easy, so it is just, you just need to do cp for copy, and then you enter the file you want to copy. For example, I want to copy my file.
24 ore prima per me è ancora, diciamo, decente.
So you need to use the myfile.txt, and then you enter the name of the new copy that you want to create. So new copy.
This copies in the same place, copy in the same directory.
Yeah, here I'm copying in the same place. So if I do ls, so I took my file here and I create a new copy with a different name. Okay. So I can do the same thing, but I copy into a different location. So I will do the same thing, but I only have to specify the location where I want to put it. So I can do my directory and new copy.
Poi dopo devo far funzionare questo computer anche dal wifi, quel problema.
Okay.
This my directory is a different place, yeah? You made it before.
Yeah, it is a different place. So my dir here is a directory in my home, and I want to create a new copy inside this directory.
Is this a default name, my dear?
No. You create the directory with the names you want. So if you want to create a new directory, you do mkdir. Mkdir is a command for creating new directories, and you can call it however you want. If you want amid dir, for example, or only amid if I want.
Yeah.
Okay, and I will have a directory called amid here. The same
I
way that you do on a Mac or a Microsoft engine. Okay.
Okay.
All right.
But we have to be careful about removing. In Linux, we cannot find it again if we remove.
So I will keep moving. I have shown how to copy a file. The way to copy a directory is the same, but you only you only need to specify to the copy command that you are copying directories, and it is used with the -r. Okay, so if I copy my dir into a new directory, I will do something like that. Okay, so I will have my dir here and a new my dir, which will be a copy of my dir. All right, so this is pretty simple, pretty basic. Nothing tricky. And we can move on. Okay, so there's also a way to move or rename directories and files. And the way to do it is using the command line mv. mv is for moving, move. Okay, so one example is I do ls. I want to change the name of this file I'm having here. And the way to do it is to do mv my file.txt, and I will give it a new name. New, or let's say renamed file-.txt. And when I hit enter, I will see using ls that my file has disappeared and it has become this new file called renamed file, and it will be exactly the same, only the name of the file has changed. Okay, and I can do the same thing with directories. So mv new my dir, and I can give it a new name, renamed dir, for example. Okay, and if I do ls, you will see that the new my dir has disappeared and it has become the renamed dir, which is right here.
So mv basically moves.
Yeah, it moves files, it renames files, and if you are using a specific way, you will be able to move files. So for example, when I do ls, let's say that I want to move this file into this directory. So what I will do is mv this file, and I will put it inside this directory. And you will see that my file save won't exist anymore in my current directory, but I will find it inside my renamed dir. Okay. And new copy file should be right here.
So basically CP and MV are the most important comments for today, for the rest of it.
Okay.
Okay.
Is it possible to have a short break or something? Just
sure.
If it's okay by you.
Actually, yes, we have been talking for an hour and a half now, so we can take a 5-minute break.
Thank you.
Yeah.
Thanks for the lecture today. We enjoyed it very much.
No problem. Okay, so let's go back in 5 minutes. And in the meantime, if there's question, I will be here to answer them.
Hello, Okba.
Hello, Amor.
Yeah, I just wanted to know, so we would be using some softwares, right, for the future tutorials.
During this first session, we won't be using any software per se.
No, for the next sessions.
The medical training will be will come afterwards with all the major biomedical applications. The aim of this session is mainly to get people on board on Linux and show them how to use the cluster, how to navigate in a Linux subsystem, and how to submit computation jobs. So this is what we will address after the break.
So we don't have to install anything onto the cluster for the future sessions, right? Okay.
No, you don't have to install anything. Everything, I think they should be available in the system. You just need to use them directly.
But okay, so in binary, I don't see anything. I mean, it's empty. I mean, so where are the others?
Okay, so let's go back to the presentation. I will try to move faster. So if you have questions, do not hesitate to write them on the discussion panel. Carlos will help to answer these concerns. Okay, so let's move on. I have showed you how to create copies of files, copy of directories, and how to rename them and move them. Now we can spend a few minutes on the text editor called VI. It is pretty tricky if you don't know how to use it, but if you know the basic, it should be easy. So the basic command is to, if you want to open an existing file or create a new file, you only need to type in VI space the file name, and then you will create the file. And you have actually two modes. You have an insert mode. So I will show you directly how to do that. So let's say I want to edit the file that is given here, a new copy of this file. So I do VI space the file name, I hit enter, and I will be in VI mode. So you will see that you have some information at the bottom of the terminal. Okay, so it will tell you that you are editing the file called the new file. It has 0 line, 0 columns, and that's it. And if you want to edit this file, you need to type in the letter I for insert, and it will display you a message at the bottom saying that you are in insert mode. So when you are in insert mode, you can type in characters, letters, you can hit enter, you can type your text, etc. Once you are finished, it's important to type the escape button, ESC but keyboard button on the top left of your keyboard. So when you type escape button, the insert display will disappear and you will be only in navigation. So you can navigate, you will see that you have a moving cursor in your file in VI, and it won't do anything actually. It will only move in the text file and it won't do anything. So I can go back into insert mode by typing I again, and I will be able to insert text, and I can move to a specific location, insert other text, etc. Okay. And then escape to leave the insert mode. The most important thing for VI is to know how to save and quit. So in order to save, you need to type the double button, the double dot, the comma. So after hitting the escape button, you type in the comma characters, and then you write W. W stands for write. So it will actually save what you have modified in your text file. So it will display you the following message saying that it has been written. Okay, and then if you want to quit, it is easy. You type in again the comma character, and then you hit the Q for quit. And then you exit VI. So it is as simple as this. There are some options that you need to know. For example, so we said that you need to type in the comma W to save. You can combine these two options. For example, if you type the comma W and Q, you will do simultaneously save and exit. Okay. So I can go back to the file that I have just edited. So I can type the comma WQ, and then I will write and quit at the same time. Okay. If you have some problems with exiting, you can force the quitting with the exclamation point here character, and what you will do, you will force the exiting, and it will exit without saving. What else? You will have access to some shortcuts. For example, if you want to, you can use in your keyboard. You have you can navigate using the arrows. Okay. You can navigate using page up, page down to move by pages into your file. You can use the home button to go back at the beginning of the line. You can use the end button to go back at the end of the line. If you press Control and use the arrows, you can move word by word, okay, into your text file. If you, what else? There are many options that you can do, and what I advise you is maybe to read about them online on Google or something like that. But the basic stuff is, you just need to know that you can use the arrows, the control arrow in order to move quickly word by word. Okay, and the home and end keyboard to move at the beginning of the line and at the end of the line. And finally, I to insert text, escape to exit the editing text, and then the comma, write and quit to exit VI. So these are the two main important things to know about VI. Okay, so if I go forward, so you have also many options. For example, you can copy paste, you can delete a character, a word, a whole line if you want. So this is what I can do. For example, if, well, I need to move using the arrows to the line that I want, and I can hit DD, double D, And this way I can delete the whole line if I want. And if I'm mistaken, I can hit the U button. It will undo my last action, etc. Okay. If I want to delete a special character, so either I enter the insert mode and then I delete using the the delete button, or maybe I do not enter the insert mode and I delete using the X, and that's it. So it should be pretty easy to know how to use VI once you have these small hints. Okay. And one other thing, so maybe you do not need to edit files all the time. Maybe you just need to know what is the content of the file. And there are two commands for that. So you have the cat command line, less and more. So you can use this command line to view what is the content of a file. So for example, if I do cat new copy of file, I can see what is the content of this file using the using the terminal. I don't have to enter the VI mode. Okay, I can do the same thing with more command, new copy, and the same thing I have. You have three commands to view the content of a file. And then when you're stuck into something like this, you can either hit escape, and if it doesn't work, you can hit Q, the letter Q for quit, and it will exit this kind of display. Okay, so moving on. One important thing is the wildcards, and these are important because when you will start working with Linux, you will have many files, and sometimes you will need to process different files the same way. For example, if I have a directory with sorry, with many files, and I want to select all the files which start with the letter S, I can display this using the star character. So if I do ls space s star, I will display all the file names which start with the letter S. I can do the same thing with D. I can also do the same thing with files which end with a special character, or maybe which have a special sequence of character in the middle. Okay, this is what I'm showing here with this example in the slides. And finally, about the permissions, and some of you had this problem earlier. When you are having a file, you will have special permissions on this file. So you can either read it, write to it, and execute it. And this is what will be shown when you type the command ls-l here. Okay, so you have, after this in this part of the information, you have this kind of data. So R stands for read, W for write, and X for execute. And the first set concerns the owner of the file. So when you create a file, you are basically the owner of the file, and you have all these these permissions on your file. But as you are in Linux, there is a type of group that exists. So you can this way share file between a working group. And if you see, you have three repetition of these characters. So the first one concerns the owner of the group. The second one concerns the group, and the third sequence concerns the the other people. So if we consider that we are in the same group, so if you do ls-l, for example, you will see that which group you belong to, and which group your files and directories are shared with. So for example, well, all my files here are shared with the read access to my group. Okay, so I think we should be sharing the same group here. And for the other people, they only have either read access or execute access. So, and these kind of things, we can change them. We're using a command line called shown or shmod. So I can show you in the slides only. It's not necessary to control this kind of things. So if I want to change the permission on a specific file, I can give, for example, my group the permission to write into the file, or I can give them the permission, or I can retrieve them the permission to write to the file. So I can do that with the plus sign or the minus sign. So this is basically the operation that you can do with the permissions. Okay, and one other important and interesting thing about Linux is that you can play with the outputs of your command lines, and this is what is called piping and redirection. So there are basically three kind of output and input in a command line. So you have the first one, which is the input. So when you do when you type in a command, the options and the arguments that come afterwards in the command line are called inputs. So for example, when I type ls-l lab/lab1, so I am basically giving an input to my command line. So this is what is called the std_in. And the output of the command is actually what is called the standard output. And this is what is printed at the, well, as an output of my command. So when I type ls, for example, this is my output. This is what is listed in my output. Okay. And you have also the third output, which is the standard error output. And basically, so if you are typing a mistake, so the message that you will be having is actually an error. So for example, I know that I don't have a directory called okba, but if I do ls okba, I will have an error output, and it will say that I cannot access to okba because it doesn't exist. So this can be categorized into the standard error output message. And what I can do with these messages is that I can redirect them into another input of some other command. So basically, what I can do, if I type, for example, pwd, I can ask for the system to not display this message inside the terminal, but I can put it into a text file. So what I will do is actually use the pipe command and then do put the message into a text file, which I can call however I want. Output example piping, okay, -txt. So what I have done actually here is that I have redirected the output of the command into a text file, which is here. So I can take a look at the content of this text file, and it will tell me the same thing as I am executing the command itself in the terminal. Okay. And one other thing is that I can take the output of these commands and then execute another command on them. This is useful for post-processing, for example. So I can do ls, for example, and then I can ask for the output to be sorted into a reverse way. So for here, you see that when I do ls, my input is sorted into into alphabetical order. But when I sort in reverse order, it will be sorted into reverse order starting from W to the letter B. So this is an example of what you can do, with piping and the redirection. And the last important thing is to know how to transfer your data from, for example, one computer to another one. And this is basically what you want to do if you have data in your personal computer and you want to transfer them to the cluster. And you have a command for that, and it is called SCP. Okay, and the idea is you always need to transfer your data from outside of Mainostream to Mainostream. So if you have data to your local computer, so you always need to be outside of Mainostream to do the transfers. So for example, if I have a text file into my local computer, so you can see that here that I am in my personal computer, I'm not in Mainostream. So I do SCP, the file, and I copy it into Mainostream, which comes afterwards. So I will have to type in my password, of course, and the transfer will start. And I can do the same thing if I have directories. So I do scp-r to transfer a directory. And the same thing if I want to retrieve data from Mainostream to my local computer. So I always need to be outside of Mainostream into my local computer, and I need to do this transfer. So I do scp Mainostream and the path to my data, and then I do the copy to my local directory. So this is the box that is below here. So to finish, I have a small exercise for you. So there is a file that we have created last year, and which actually summarize all the comments that I have presented and even more. And this file is under this this path in this location. So this is actually what I need you to do. I need you to create a directory in your home space, which you can call it actually however you want. You can call it my documents, or however, feel free to choose any name. And I want you to copy it, the cheat sheet file, it is an Excel file, into your new directory, and change its name to my cheat sheet.xls. And then I want you to use the scp command line to transfer this Excel sheet into your local computer. And then you can open it with your Excel reader if you want. So take 5 minutes to do that. It is important to succeed, and then we will move forward.
Excuse me, this file name or folder name, GPFS.
Yeah.
This is in the cluster address, or
yeah,
is it
you just need to go to this directory, and you will see that it exists, and you will find the file in this directory. So you already know the commands to do that. You only need to do a cd space and then the path that I have given here.
I see.
Yeah.
Because when I put ls, basically I see like beam. I made this my documents, my file.txt or work directory. I see just 4 files, but I can try
you need to move to this location in order to find the file.
Okay, so I should just put cd and then this address /.
Yes, exactly.
And this is basically under home directory in supercomputer.
No, you type exactly as it is. cd /gpfs/project/nct/nct0004. And then in this directory, you should find a file called cheatsheet.xlsx.
I see. Yeah, I found it here.
Mm-hmm. So go ahead and keep doing what is asked in the PowerPoint slide.
Yeah, you were saying for transfer, we should use SCP.
Yeah.
So actually, when I use ls, I can see this now. Cheat sheet xe.xlsx labs.
Hello.
For using, hello.
Hello.
Yes.
Yes. So I have located the file, but I can't get outside the file. When I put the escape button, it is not coming out of the file. What should I do?
I'm sorry, I did not understand what you have done with the file. Can you repeat?
No, I just located the file in that particular space.
Using VI?
Yes. So now I want to get out of that file. So I can't get out of the file with by pressing the escape button. What should I do now?
No, escape button doesn't exist. The file. You need to hit the the colon button and then the Q touch, and then you hit enter.
Double colon.
Yeah. If you look at in the discussion panel, this is how you quit. You type escape and then you enter these two characters.
Excuse me, Okbar, just a naive question. How do we get from our home directory to the directory GPFS, etc., to get the sheet?
You use CD space. Yeah.
Yeah, I did put CD space and the path you specified there, but it's telling me bash. It's giving me a bash, no such file or directory.
It means that you have done a mistake in the name of the the directories. Just make sure that you are typing exactly this, the exact same words.
Okay. Yes. Okay. Instead of NCT, I was typing NTC. Yes. Thank you.
Yeah. Yeah. No problem. So if we want to go a bit quicker, I can show you here how we can do that. It's just that we are running a bit out of time. So let's say that I am in my home directory. And as I said, the file is located into another directory. So what I do is I go into the new directory. So it is called GPFS. Oops, GPFS. And then it is under projects. And then it is under NCT00. And then it is under NCT0004. Okay, I hit enter. So I move to this new location. I do ls. I see that, okay, the file is right here. It is called cheat sheet. And there is a small, let's say, a small problem. It has a space in it. So what I need to do is, well, I will need to take into account when I do that. So I asked you to copy. So I do cp cheat sheet, and I will move it to my home directory. So, and I told you that there is a shortcut to home directory using the tilde character. Once I have done that, I hit enter. Okay, so I can go to my home directory. And I should find the cheat sheet right there. And it is right here. Okay. So what I will do, I will change its name because I don't like spaces in the namespace. So I will do mv cheat sheet into cheat sheet, and then I will just delete the space, and I will insert a dash. And here it is. It is a clean name without any spaces. And now what I will do is I will transfer this file into my local computer. So what I do is SCP, but SCP from my local computer. So I open a terminal. Okay. I do mkdir BSc Winter School 21. I go into BSc to this directory, and then I will put the command line to retrieve the file from BSc. So I type in my login, nct 404 @bsc. No, it is mn1.bsc.es, and I want to retrieve the file called cheat sheet, which is here, and I want to copy it into my local file here. So it will ask me for my password, of course, which I have forgotten. So what I'll do is I will go into my email address, and I will look for it. So, okay, it is. I hit enter, and up, it is downloading. I do ls, and it is in my local computer, if you see here. So in this machine represents my local computer, and I have transferred the file from BSc here to my local computer, which is represented by a dot. Okay, so I hope you all have succeeded into performing this operation.
I think I had an issue because when I put this function which you told me, it is showing that no such file or directory.
Well, it means that you have something wrong into your into the path name or the file name. So you need to make sure that it is in the right location and it has the right name. Just double check your inputs, and then let's see. So make sure that your file is in the correct location, and when you do SCP, make sure that it points to the right location.
So when I change the directory to GPFS, I should type vi cheat sheet xs, right?
No, you don't need to type vi. Vi is used only for editing. So I did not ask you to edit the file. It is only asked to move the file from the let's say the project directory into your home directory, and then from your home directory you need to use SCP to download it to your local computer.
Okay, so I will put CP cheat sheet xs, right? Copy.
Yeah. You need to copy it to your home.
Okay.
Indeed.
So
yeah.
I will put that after this button, and so now it is showing the same. Now what should I do here after this? After CP, then I need to put.
After you copy the file into your home directory, make sure that is that it is in your home directory. So you do ls to see if it is there or not.
So it is saying that no such file or directory. Now when I press ls, it is showing cheat sheet xls labs.
Yeah.
So now.
Okay, so you have to take into account that there is a space in the name of the file, and as I have showed you, if when you type a when you do a CP with a file with a space inside in the name, you need to do a backslash, just like here. Oh, sorry.
Okay.
Okay, so it's a bit tricky. So just like I did here. So you need to insert a backslash in the name to take into account the space.
Okay.
Or as Amor said, you just type in the first letters and then you type tab and it will complete, and the Linux system will complete the name for you.
Do you mind please going back to the command that you put to transfer the file to your local computer?
Yeah, sure. So in order to
yes, so now I should put, after CP, I need to put what?
Well, after CP, did you finish copying or not?
Yes, it is done now.
So you need to do the SCP operation. You need to copy from the Marnostrum cluster to your local computer. And in order to do that, you use SCP, the command SCP.
SCP.
So in order to do that, you always need to be outside of the cluster. So you need to open a terminal. Okay, you open a new terminal from not in BSC.
Outside BSC?
Outside BSC, yeah. So if you're using Mac, you only open a terminal, classic terminal, okay? If you're using MobiXterm, you should have a terminal here in the list of your sessions. You should have a terminal session here. Okay, so you double click on it and you will have a nice terminal to display.
If we have a Windows, we should open a new terminal, yeah? So we need to...
If you're using Windows, as I told you before, I'm not sure that you will have access to SCP from the command line of Windows.
Oh.
You can try, but last time I tried, I did not succeed from the command line.
So what should what's your recommendation in this case?
Well,
for Windows users,
for Windows, you either install putty or winscp. There's a software called winscp, I think, or you can install MobiXterm, just like I did here, and you can transfer your data from in a graphical way.
Oh, you mean by a star, using a star?
Yeah.
Actually,
so, but we can take some time afterwards if you want to look at the specific points, because we need to move forward.
Sure.
Yeah, I'm sorry. I mean,
so do you mind please addressing my question? So if you can go back to your actual terminal where you type the...
Yeah. So when I go to my terminal, so this is the command that you need to type in to retrieve your data. So it is...
Yeah, but the NCT, that's yours, right? The NCT.
NCT is my username, so you need to use your username and your password.
Yes.
Okay.
And so what is the address of the supercomputer? But what is this? So why this?
And then this comma is to say the address ends here, and then this is the path that is coming. Okay.
Understood. Yes, thank you so much.
So you put the comma, and then the tilde is to say that it is in my home directory. And under my home directory, you will find the file in question, and I want you to copy it into
Thank you very
my
much.
current document. Yeah.
So Windows users, we can discuss this later, how to copy this.
Yeah.
Okay.
1 minute. So how to open this terminus? Because I can't open on Mac this terminus again.
No, you on Mac it is easy. I think you have a button to list all your applications on Mac. It is on your keyboard. You list all your applications and you start typing terminal, and it will give you your terminal. Okay, so now we need to move to the Slurm part. It is important to cover this section. Okay. So, but quickly, Marnostrum is a strong. It is a strong cluster. Cluster is actually the name of a supercomputer, which is an ensemble of multiple processors. So Marnostrum 4 has Intel Skylake computer, and they have up to, I think, 165,000 cores and a huge amount of memory. Okay, so it is a pretty sophisticated computer because it is able to execute a lot of things. And today, the advanced computers are able to do things simultaneously. And this is what you can see here with the different instructions of vectorizations that you see. So don't worry if you don't understand completely the words that I am saying. So if you're an expert, you will be able to understand that. But I mean, for the training, it is okay if you don't understand. It's fine. It is just maybe important to hear about this kind of things. So the important thing is that there is a vectorization instruction that can be used, and this vectorization will able to accelerate the computations of your program. Okay, so in a supercomputer, you have not only one processor, but you have thousands of them, and they are all interconnected with a network. And this network is a high-speed network which is able to transfer data at the speed of 100 gigabytes per second. And each processor has access to a local memory. It is attached to it, and it is about 200 gigabytes. And also it has access to a shared file system, which called actually GPFS, as you said earlier, as we have seen it. And as we have tried at first, when you logged in, you have 3 public login nodes, MN1, MN2, and MN3. As you may know, there are several hundreds, maybe thousands of users on the supercomputer. So it is important that all the workload, all the connections are balanced between these 3 login nodes. So if in the future you are not able to connect through MN1, maybe you need to try MN2 or MN3, because all the users may have completed the quota on MN1. So in order, when you are on the login nodes, you will be able to compile your programs. So if you have done some programming, you know that when you write a program using a programming language, either Fortran or C or C++, you will need to compile your program into a machine program in order to be able to execute it. And to do so, you have access to 2 compilers. This is done using a compiler. So there is one called it is a private it is not a free software, but you have to pay for it. It is Intel compiler. So they are available in the login nodes. So you're able to compile your program using either, if you have written your program using Fortran, you can compile it with iFort. So it is the Fortran compiler of Intel, and you have access to the free software called GCC. It is available by default in the cluster. And so the default version is 4.8, but you have access to other versions which are installed, and you will see how you can access them later on. Okay, so the compilation allows you to transform your human readable program that you have written yourself into a text edit into an understandable, a machine understandable program. Okay, so as I said, there is a file system that you can use in the cluster. There is the root part where all the system is installed, and this area you should not be able to touch it as you don't have the permission. But there is also, you have access to other areas where you can put your data, store it, and compute your jobs. So the advantage of the GPFS system is that it is a parallel file system. So you can address this file system by multiple nodes, multiple instances and tasks. So, and it is performant. And you can write also at high speed a large amount of data and read and write at the same time. So as I said, you have your home directory under GPFS /home/ your username. So basically, if these are the good usage. So in your home directory, you don't do computation. You do only, storing and maybe editing of files. So if you want to do computations using, a large data set, and if you want to write and read a lot of files, you need to move to the Scratch. So in the GPFS, you have a directory called Scratch, and you will find also a directory with your login name. And this is where you should do your computations. So later on, we will see that when you are submitting a job, you will need to move to the Scratch section in order to perform your computations. And also under the apps directory, you will have a list of all the applications that are installed and provided for the users. And as I said, each CPU, each processor have attached to it a local storage, and it is a fast access local storage. But you need to be very careful, because every time you submit a job, you perform a calculation. This kind of storage is erased at the end of your computation. So you need to make sure that you move this data away from this storage into the GPFS file system before you finish the job. Otherwise, you will lose access to your data. We can come back to this specific point later if you want. So now we will see some interesting tool called module, and we will see how you can use what is the available software to you for the remaining training session. So if you go back to your terminal and you type this kind of the first command, you will see that it will display you some information. I just need to retrieve. Okay, so it is right here. So if I do module avail, I will see that I have a bunch of applications available to me that I can load and use actually. So feel free to type in this command and you will see the kind of output that you have. Module avail. I hit enter, and you can use the enter keyboard to finish listing all the applications. So if you are into math, you will see that you have the R program, which is for statistics and probabilities. You will have also, I don't know if they have Octave, which is the free version of MATLAB if you are into math problems. You have OpenFOAM, Amber for chemistry. What else? I mean, half of these applications, I'm not aware of them. Quantum Espresso is mainly for quantum chemistry. What else?
What was the name of this command you put actually in the login?
It is module space avail.
Okay, module.
Okay.
is avail.
Yeah. So you have this basic command. So you have module avail, you have module list. If you start with the command module list, it will tell you the modules the applications that you have loaded in your system. Okay, so by default, you should all have the Intel compiler, the version of 2017. You have the Intel MPI library, the Intel MKL, and a BSC module, just like I'm showing you right now.
Actually, when I put this one, module avail, for example, like open form and those things doesn't show. It more shows like.
Yeah, because I typed in a different command. You need to type in module list instead of module avail.
Oh, so
module avail will show you the, it's a kind of catalog of applications that you can use, and module list will give you the list of the applications that you have loaded. So it is quite different.
So in order to go back to the home directory, we should use escape or?
No. To go back to your home directory, you just type in CD and then enter. Because but it is not the question. It is not the question here. It is independent from your location when you type this kind of command. Okay.
Because what I can see here, it shows, for example, lines 31, 59, and then this is blinking. So I was wondering how to go out of it. Now I can see open form, for example.
Yeah. Okay, but the most important thing is that you need to know how to use these modules, because that's what you will be using later in the training. Okay, so for example, if I want to use, as I said, if I do module list, I will see that I have some applications that are loaded by default by Mare Nostrum. So what I can do is actually I can unload all this environment. So what I can do is module purge. So it will unload all this environment. So if I go back to module list, it will tell me that I have no modules loaded. So what I can start doing is I can start building my own environment. So I will start doing a module load of, okay, I need a specific version of the Intel compiler. So I will use the Intel, and I will start using the tab command, the tab keyboard. It will give me all the versions that are available. So, okay, I want to use the latest one. So the 2020.1, and up, it should be loaded. So if I do a module list, I will see that it is in my currently loaded modules. Okay. I can, for example, load a open form if I want. Sorry. Module load open. So open form, you have, a bunch of version installed. So maybe I want to use the version 6.0. So, okay, put it on the file before execution. So, okay, so it will be loaded, but it is giving me a message to do before I execute open form. Okay, so in my list of loaded modules, I will have open form and Intel compiler. Okay, so I can do a module purge to unload all that. I can check if everything has been unloaded properly. Okay, so I can go back to my default environment. So BSC / 1.0. Module load BSC. Okay. All right. So once you have seen that, you can practice this kind of exercise, module load, module unload, if you want to unload a specific version, module swap if you want to switch between two different versions, etc. And still keep in mind that you can always look at the modules that you have listed using the module list command. Okay, so there's also the BSC module, and this one is interesting because it will give you the kind of resources that you have access to. So in this example, that if you use the command BSC quota, it will give you how much memory you have access to and what is the limit, either in the home, the project, or the Scratch directory. We have also the BSC queues, and the important thing about these queues is that it will show you what kind of compute resources you have access to. So, for example, in the debug queue, you will have access to 786 processors, okay, cores, and the same. And you will see that you have a maximum of compute time, which is here 2 hours. Instead of in the training queue, you can compute up to 2 days of running using the same amount of processors.
Yeah, hopefully.
Okay, so we can keep going. So if you have in the project directory, in the slash gpfs project nct 00/nct 04, you have a directory called labs, and in this directory you have 4 subdirectories, and in this I think in the second one, no, in the first one, you have a text file that you can read, and you have all this kind of command that you can play with. So you can select this command here and execute them, and so it is easier for you to see. Okay, so do not hesitate to copy this directory into your home and play with them at your convenience. So I will move forward to the next part. The next part is about Slurm. And Slurm is actually very important because it is the way that you will be able to launch your computations. Okay. So Slurm is actually the acronym for Simple Linux Utility for Resource Management. So this is what will be used to, request computation resources for some amount of time. And as you understand, you are not the only users on Nostrum. You are maybe several thousands. So in order to make the computation fair for everyone, there is some kind of queue that when you submit a job, your job will go into a queue and it will wait for its turn to be able to be launched. And this is what Slurm basically do, all the time. So there's some basic commands that you need to know. Sometimes, depending on the cluster, some commands are available and some are not. So some of them will work, and basically, SQ, the command SQ, which actually lists your pending or running jobs, will work. Sbatch is used to submit a job. Scancel is used to cancel a job, and sran is also used to initiate a job. So, for example, you can type in these commands and see what happens. We can type isinfo. Okay, so you do not have access to this information, so it is not activated on my Nostrum, but you can type in SQ, for example, and it will tell you that, okay, so you have no pending jobs or running jobs on the list. All right. And if you have a pending job, you can ask to cancel it using scancel, for example, and you can submit the job using sbatch. So in the labs, you can see how we can do that. Okay. So there's also one thing that is interesting. So you can launch your job either using a batch mode, which means that you can set up a bunch of instructions that you want to execute and then give it to the system to execute them. Or maybe you can execute them, but interactively. It means that you want to see directly what is the computation doing. So what you can do is actually request for a job for an instance allocation. And how to do that is you can do, for example, salloc, the command salloc, you request a specific number of cores. Here I need 1, and you hit enter. So if this is basically doing, it is allocating it is searching for a resource that is available to us, and it will start configure it and then give us the hand to use it. So here my job is still, it is queued and it is waiting for the resource. So you need to wait a little bit. So I will come back to it once it is ready. So if you are lucky, it is quick if nobody is computing, but if you are unlucky, you will have to wait some time to have the resource. Okay, so here, for example, I prepared the output for you. So what you see here is that when you do the request of allocation, okay, so here it is working. Okay, so what it's saying basically is that it requested for resources. It has been allocated, and we have been given a job ID, and the resource is been configured. And then, okay, so we have been given the node with the ID S01 R1 event B27. And if you notice, you see that we have moved from, you know, the Mare Nostrum login node into this new node. So what we did here is that we moved from the login node into the compute node. And basically is that here we're able to do computations if you want to. Okay. So we have not moved a directory, but we have moved from one resource to another one. And here we can do some calculations. So we can still do the basic computation, but we can also do some calculations. I don't know, execute some Python script, or maybe some R script or OpenFOAM or whatever, but in interactive way. And once we have, sorry, just let me finish 2 seconds.
Okay.
And once we have finished, you always need to exit the compute node in order to, you know, to free the compute resource. Okay, so when you type exit, you see that you are exiting and you have a message saying that you have released the allocation, and somebody else now can use this this computational resource to perform computation. And we have come back to our login node. Okay. All right. So if we move forward, okay. So
excuse me.
Yes, sure.
Yes. So in the when you define, when you run the command salloc, so you didn't specify, you didn't give any specifics in terms of CPUs or memory users. Is there a default?
Yes, you always have a default configuration. For example, you always have a default time. I think most of the case it is 2 hours, dependently of the configuration, but you can request a specific amount of time. If you need only 10 minutes, for example, you can ask for 10 minutes only. You can also ask for like a specific amount of memory if you have special requests, but usually you always have access to a default configuration.
Are we addressing like the rationale of specifying this criteria?
Yes, I will address them later, but not in the srlog configuration. In the bash script configuration, I will give some more options. Yeah.
Thank you. Thank you so much.
Yeah. So if you execute the BSC queues on your terminal, you see that you have access to different queues. So the interactive queues is the one that I have just used using the interactive mode with srlog. But you also have access to a debug, a training queue, for example. So it's not always the same. So depending of the administration of the cluster, you might have access to different queues. So for this training, it should look like something like this. And you can address the different queues by using this kind of commands and options into your script. Okay, so you do a dash key QoS equal, the name of the queue name here. Okay, and this is an example of when you want to perform calculations, but using a batch script, which is different from an allocation with an interactive mode. So you can start writing, your script and specify all kind of options that you want to use. For example, you can specify a job name here. You can, address, a special queue that you want. You can request a specific number of tasks or cores. You can specify the time of your computation. So be aware that if your job runs only for 5 minutes, it is important that you do not, overestimate this computation time. This is important because sometimes, the Slurm software will be able to launch your job quicker than expected, as you may move up the queue in the Slurm. And also you can specify the output of the name of your output files. And finally, once you have specified all these options, you can start, setting up your software using the module if you want to compile or if you want to execute stuff. And then you launch your application using either sran or mpirun. So for the launching, this is specific to the application that you use, and it will mainly be addressed, in the following sessions later this week. So there are some aspects of, as I said, depending on the applications. Some applications have only a sequential or serial, let's say, implementation. So you only need to have access to one task or one core, and you will be able to launch your application, this way. Or sometimes you have access to applications which have parallel execution. So it is either a shared memory implementation using OMP, or it may be a distributed memory approach. So in a shared memory approach, you only need one task, and you need to specify the number of threads using a certain number of CPUs per task. And this is how you need to implement your script in order to launch your job. But in the other way, using a distributed memory, so what you need actually is a larger number of tasks instead of a number of CPUs per task. And this is how you will implement your job. And in the this kind of jobs can be combined, and it is called a hybrid job. So for each task, you will have some subtasks or CPUs per task. So in this example, you have 4 tasks, and for each task, you will have 24 CPUs, which will help you to perform the calculations. So overall, you will have 24 times 4 number of CPUs that you will use. Okay, so the best, and also more about the options. So you have also some options in order to address the memory issue, as you are asking before. So you can, if you have an application which is very memory greedy, so you can ask for more memory using this kind of option. So dash constraint equals high mem. So using this option, you will be able to use some nodes which are equipped with a larger amount of memory, 384 instead of 96. Okay. And there are also some other options, but I don't know if you will be able to address them during this session or not. Okay, and also there are some other options which are maybe specific to you know, a bash scripting mode. If you want to use or retrieve some information about your jobs, for example, the job ID or the number of processors that you are using or nodes, you will be able to access this data in your script using this variable environment. And finally, if when the time comes to submit the job, you need to make sure that this file is executable, and you need to do to make it executable using the chmod command line that we have seen earlier. So you need to type in this command line, for example. So we can take some questions, and in the same time, you can take a look at the labs. So I think it is the one that is located in still in the GPFS project NCT00/NCT04/labs, and it should be lab 2. So you have some applications that will be compiled and to produce a binary. And if you read through the README file here, you will see how to launch this kind of applications. So take some time, launch these applications, and if you have trouble.
Just one question. Actually, I am in NCT00004.
Yeah.
So not sure what should I do actually next to go to this
you can copy this directory into your home, and you can start launching these jobs using sbatch.
So you mean I should use CP for copy when I'm in NCT0004? I'm not sure.
Okay, so did you do CD, GPFS, project, NCT, etc.?
Yeah, I did CD, G.
Okay, so what you do now is you do CP space -R to copy the directory, and you copy the labs directory into your home using the tilde.
But I think I am now in NCT0004.
Yeah, this is my home. So
is this the correct one?
Yeah, it is the correct one. Yeah.
I see. So now
you do ls. You need to do ls to see if there are the labs there.
Yeah, I did ls, and I can see cheat sheet, Excel, and
labs. Yeah.
And lab.
Yeah. So copy labs into your home.
So in order to do so, I should use CP labs.
Space -R.
Oh, -R.
Yeah, because it is a directory. Okay, so I will, if you want, I can show you here how we can do that. So once you have copied this lab into your home directory, you can go into labs 2, for example, and you can take a look at the README file. So what it says is that, okay, welcome, etc. You can take a look at before the first job is actually to submit a batch script, and it is called run batch script.slurm. Okay, so what we can do actually is look at this batch script, what it does actually. So when I open this file, what I see is that, okay, so I am specifying a job name. I'm requesting a certain number of tasks here. I am asking for 96. I am requesting for a 5-minute computation. I have specified the name of the output files. Okay. What I have done later is I have purged all my environment, so it doesn't have any anything that I don't want to. And I did a source of a specific environment. So we can take a look at this file, but basically what it is doing is that it is loading Intel 2018 version with the MKL, okay? So this is basically what it's doing. So in this script, I do some basic stuff. So the first thing I do is I print the date using the date command. I print also the current directory. I launch a job called hostname, and basically what it does is it prints the name of the CPU, okay, the ID of the CPU, and also it does a sleep. It doesn't perform anything for 30 seconds, and then it finishes with the date. So what we can do now is actually launch this job using sbatch, run batch scripts. And then it is submitted. And I can monitor my job using the SQ command. And what I see is that it will tell me. Okay, so it tells me that my job is in the queue using under this name. So I am the owner of the job. And here I have the status, and PG means pending. And this is the number of nodes that I have requested. And this will give me the list of the nodes that I have access to. So I can recall again the command line and see what's going on. So it will remain in pending until we have found all the resources available. Okay. What I advise you is actually to go into the batch script here, and what you can do is go back up, and instead of requesting 96 tasks, you can start by asking only 2 tasks, and maybe not for 5 minutes, but for 2 minutes. Okay. And try to redo the same operation. Batch script, and do SQ again. So in the meantime, for example, if I have changed my mind and if I want to cancel one of my jobs, I can do that using scancel, and I can do it with the job ID here. So I copy the job ID and then I paste it, and it will be canceled from the queue. So if I do SQ again, I will see that, okay, so my job is terminating. Well, I wasn't lucky here because in the meantime, my job has been launched and it was over. Oh, no, actually it was canceled. Okay, so R stands for running. So my job is actually running, and I can see the output of my jobs. So my output are named this way. So I ask them to be named with job and then underscore and the job ID. So the last one I have launched is the 86. So I can take a look at the content of this file. So as I requested, I asked in my job script, I asked to print the date and then the current directory. And then there's an app. I asked for the host name. So as I have 2 tasks, I have 2 inputs here, and then finish with the date. So my job now should be over. And then I have nothing in the queue. So what you need to do now is to try to launch the other scripts. So you have this one, the bash script. You have the OMP script, the MPI script, serial and hybrid. So try to play with them and see how everyone behaves and what is the input, and try changing the number of requests. Yeah.
So I am stuck still with the second terminal because I opened the second, but I can't open on my MacBook. So I am right now at the GPFS project NCT00 NCT00004, and that's it. So I need to change, you said, to SNP, right? SNP? NCP, you said.
NCT.
I need to change it.
Yeah, what you need to do is to copy the directory called labs, which is available in the path that you just said, and you need to copy that into your home directory.
Okay,
this way you will be able to launch your jobs.
So I have to put CP labs.
Yeah, you need to do CP-R, space -R, because it is a directory.
Dash R.
CP space -R space labs, and then you copy it into your home. Space tilde.
Yes. So it is saying that missing destination file like this. CP-R. Yes, it is saying that try CP help for more information.
Well, it means that you haven't typed in CP the right way. So it should be CP space -R CP-R space, and then the path GPFS, as Carlos have noted it in the discussion panel.
CP space -R space labs. Yes, but it's not.
Here, Carlos just showed you how to do that in the discussion panel. But in order to do that, you need to be in your home directory, as he said, but not in the Scratch directory. Okay, so let's move on. I hope you all you were all able to submit these scripts, and you all have been able to look at inside the scripts and look at the output of these jobs. It is important to know how you can play with them. So it is quite easy. So you just need to do sbatch. For example, if I take the OMP job script, so it is requesting 1 task and 8 CPUs per task. Okay, and one important thing is that you might have some errors because it is launching some binaries, so you need to compile the programs first. So if you do the README, you just need to follow the steps. So first you need to compile module load Intel 2018 -.4. You need to compile, and then you need to run sbatch run serial, and it will be able to compute. Okay, so make sure you read through the README, because there are some instructions as we are launching OMP programs, so you need to be able to compile them with the commands, either with ICPC, Intel compiler for C++, MPI, etc. So make sure that you compile the programs before you do the sbatch. So for the rest of the session, we will speak about compilers and optimizations. So if you want, we can spend more time on the SLUM, so the submitting gaps. May I remind you to please mute your microphone when you're not speaking, so we do not disturb everybody. So the compilers are interesting because they will allow you to transform your code from a programming language into a binary program that the computer will be able to execute. So on Mare Nostrum, you have two kind of compilers, maybe more. You have maybe more with the PGI, for example. But the mostly known are Intel compiler and the GNU compilers. So in order to compile a C or C++ program, you have access to ICC and ICPC. With the Intel, with GNU, you can use GCC and G++. And for Fortran, you have iFortran and GFortran. And they both provide support for OpenMP. And in order to do that, you specify the option, the -q OpenMP or -f OpenMP during your compilation. And this, if you are writing parallel programs, you need to use MPI compilers. So this is a wrap-up for a message passing interface, and in order to do that, you need to compile your program with MPI ICC for a C program or C++ program, and IPI ICPC, for example. And you have the same version with GNU with OpenMPI, and you have the listed compiler here. And one interesting thing is that when you do some programming, you have access to some free libraries, just such as the MKL. MKL stands for the Math Kernel Library. So you have access to some mathematical functions, for example, the cosine, the sinus function, etc. What else? The power function, the square root function, etc. So you have access to this kind of function using the MKL library. And you have also access to some other contents, such as operation on vectors and matrices. You can do fast Fourier transform, for example. You have access to linear algebra operations such as solving least square problems, eigenvalue problems. You have access to also Scalapack, which is a distributed derivation of LAPACK. LAPACK, as I said, is the linear algebra package, etc. So in order to not having to implement this kind of function yourself, you can access these kind of libraries and use them for free. And they are fast and optimized and do not have any errors in them. So when you do so, make sure that you link against this kind of libraries. So when you are compiling, so you need to add the -mkl equals sequential if you are using a serial problem, or parallel if you are using a multi-threaded problem. And if you are having some trouble, you do not hesitate to go to the MKL link webpage to get some help. It will there's a lot of documentation, and it is very easy to navigate into these websites. So as I said, there are a lot of functions that are implemented. You can either find them in the math library or the Intel math library. So some of them are optimized for Intel computers, as you are running here on Intel processors. So when you're running on Intel, do not hesitate to use the Intel math library MKL, because it will be optimized and it will run faster, for example. So you have the example of the power function, which can run up to 3 times faster compared to the standard math library.
Just one question. This math library is based on Linux. Is it? It's a
yes,
kind of
yes.
Okay.
Yes, it is. There are functions which have been coded and stored into, let's say, a library. So when you need to access that in your program, you just need to, you just need to call the library or the function itself. And the thing is that you, at the compilation, you need to to be careful and link against the right library.
So because like the reason I'm asking this, like in Windows, we have used MATLAB, we use Python, and this MATLAB is not a Python one in Linux. Is it an independent Linux program?
Yes, it is independent. It is stored in a location. So, for example, if you do a module load on your on Mare Nostrum, you will see that you have no, a module list. Sorry, you will see that you are in the list. You have an MKL line. So, and this is what it refers to. So, when you load the MKL, you will be able to access the function in the MKL.
But these ones are something that are tied to your cluster, or is like we can access to MATLAB on a Linux computer at home also.
You can access to that, but you need to download it and install it.
I see.
Yeah.
So this is a library that needs to be installed on top of the Linux system.
Yes, of course.
I see. Thank you.
You're welcome. And that's it. Do you have any questions about compilation? Well, I did not insist very much about the compilation because I understand that you will be mainly users of programs, so you might not be very interested in the compilation itself. There is specific courses, I think, that you can take for to handle programming languages and compilation. It takes more than half an hour in order to be able to master this kind of topics. So this is just for a general information for you to know.
Yeah, but what is the general purpose of compilation? Like, what is the benefit of it, and is it, for example, required for like omics studies and
Well,
stuff like that?
The benefit is that, for example, let's say that you have, if you are a developer and that you are writing a program because you need to write a program for processing some data, for example, perform an operation on I don't know, perform solve a problem, for example, a linear matrix, as AX equal B, you need to solve that. So the compilation will be able to to transform your handwritten program, for example, here, as you see, from something that you can write and understand yourself to something that the machine can understand and execute. So this is the main purpose of the compilation. I don't know if I have answered your question.
Yes, you did. Thank you. Appreciate it.
Okay, so what I suggest to you with Carlos is to spend some time on the labs, and I let you 10 to 15 minutes to, I let you, try to launch the jobs using Slurm, because I think it's very important to be able to launch some jobs and cancel them and rerun them and look at the output, etc. So I will let you do that for like 10 or 15 minutes, and if you have questions, we will answer them for you.
So the only issue is that we don't have the slides, so we can actually cheat sheets and see the commands that we need to run. I don't memorize all of them.
You have in the labs, you have a file called README.
Okay.
Okay, so take a look at this file, and it will tell you what to do step by step. So if you need to compile things, you just execute the command, and then you have the sbatch, etc.
Thank you so much.
You're welcome.
running the there was this run hybrid dot slurn in lab 2. So one of the commands is srun dot slash hello underscore hybrid, like in the script. So dot slash is an executable, right?
Yes, indeed.
So where is this executable?
Well, this executable, if it is not in the current directory, it means that you have to create it. And if you take a look at the README file, you can create it using the compilation line given here. Can you see my screen?
Okay. Yeah, I can see.
So make sure that you have loaded the Intel compiler and the Intel MPI with the module command. So do a module list to see if you have Intel compiler loaded, and then you will be able to copy paste this command into your terminal to be able to compile the program.
Oh, okay. And if I say I don't want to run any of these, I want to load a separate module, like GROMACS, for example. So how do I know which compiler to use?
For GROMACS, I won't think that when you load the module, it will be you will be able to use the application directly, since it will be already compiled. You don't need to compile GROMACS, for example. If you load the module, you will have directly access to the application.
So I do module load GROMACS, and then I write a batch script and do an batch directly.
Yeah, exactly.
Okay. And like, so when I did module load GROMACS in here, like I couldn't see all the different versions. And when I did module avail, I could see the different versions. So how do I select?
Sorry, Amar, can you repeat the question? I apologize.
Okay, so when I do module load GROMACS,
yeah,
for example, it's giving me just one of them. Like in your case, there were so many versions, right?
Yeah, but maybe they have only installed one version of GROMACS.
But when I do module avail, I see different versions, like 20,
well,
20.
You can select the specific version that you want, and you can type it by hand if it's not suggested. But okay, so if you are comfortable with the examples that I have given here, you can go to GROMACS, for example. But if you are not very comfortable with Slurm already, I advise you to look at the different scripts that I have provided. And once you have managed these, you can go to more complex applications. It's my advice. It is my advice.
Yeah, sure. Thank you. So like how many days will I have access to this account?
I think you will have access for the whole week during the training session.
Okay.
Yeah.
Okay. Thanks a lot.
So also, can you please briefly comment the meaning of this this ICPC commands that come before running the S batches?
ICPC means that you are invoking a compiler. So it means that you want to convert a program that you have written into an executable program by the machine. Okay.
Yes, sir.
So has everyone been able to do some stuff with these scripts? What kind of outputs did you get? Did you get any errors or something like that?
So I actually ran them, and so the job is running, but I'm not sure what kind of command I can run to actually monitor the processes and see whether the job was complete or Did go, not go?
Well, you have the command called sq.
Oh,
sq will show you if your job is running or pending or completed. So if there is nothing in the list, it means that all your jobs have been completed.
Okay, okay, understood.
Yeah, and if you take a look at inside your current directory, if you do ls, you will see some output files called job underscore and job ID with the extension .out or .err. And you can
Yes,
take a look at
yes, I
the
actually
content
got
of these
all of them.
files. Yeah.
Yes, I think all of them will be run fine. Yes, thank you so much.
Mm. Was everyone able to see his job in the SQ list, for example, in a pending state or a running state? Was everyone able to cancel a job while it is in the queue using the command scancel? I encourage you to do this kind of exercise. It's very important. So the general idea when you want to submit a job, for example, if you want to launch an application, let's take the OMP example. So I have this batch script which requests for some resources and a computational time. So what I'm doing actually is, once I have all this configured and loaded, I will run my application using this command. And I will have actually, when I submit the job, for example, here, I have submitted my job using sbatch run OMP. And then when I type SQ, I see that my job is in the list and it is pending. And at some point, it will run and finish. So this is what happened here. So I have an output. So I have a standard output here, the out file. So what I see is that my program has executed, and this is the output of my program. So basically, the program is a Hello MPI, a Hello OpenMP program. So what I'm asking in this program is that each process, each thread that is being run prints a message, and it tells that this is okay. It tells this I am process number X, and it will finish at the end. And at the end, I will display the computational time that it took to run the whole program. So this is some basic stuff that this program does. Okay, and you have access to the output thanks to the job.out file. So Carlos, did you want to comment a bit more on this?
Yes, hello, Okba. Sorry that
Yeah.
I was trying to
no problem.
answer some questions here. Well, so regarding the files, then I think that you already commented the essentials about how to use the files. The only thing, well, I was commenting also is to just think about some details that are, let's say, more related to Linux rather than to using the cluster in a way. But maybe if I can just comment.
Yeah, sure. Go ahead. Go ahead.
Yes, in Linux, actually, everything that you have is a file. In a way, and whenever you want to execute something in the cluster in a supercomputer, you define this as a JavaScript, as we have commented, and the JavaScript is actually a file that has commands inside it. Essentially, there is nothing more than, let's say, everything that you are typing step by step in the terminal, you execute it, and then it gets you to let's say you change the directory, you create a file. These are commands that, as they return immediately when you execute it in the terminal, these are commands that you can also put inside the file and execute it as, so to say, as a batch script. That means you can tell the system, I want to execute these commands, and just let this file be executed directly. This is a bit what you have seen with the README file, readme.txt, which is actually possible to execute directly. And whenever you have this set of commands that can be executed directly in a terminal, when you may have one of these commands that is particularly intense, that is a whole simulation. And in this case, you should use the system with the batch scheduler, with the Slurm scheduler, because if you execute in the terminal as you are now, you are executing inside one node. Somehow you have connected to the system and you are inside one simple computer. This login node where you are working is maybe similar to your laptop, or maybe just a bit more powerful than your laptop. You cannot execute something that is very much time consuming and intense inside your laptop. If you need, let's say, many computers, many nodes, so to say, of the supercomputer, or many CPUs, you need to define this as a JavaScript. And the way to define a JavaScript is actually creating a file, putting the commands inside the file, and including the sbatch directives that you have seen in these files. The lines with the hashtag sbatch, the ones that begin with the hashtag sbatch, are the ones that are telling to the scheduler, hey, I want to execute all these commands, but please take care that you have these resources allocated for me with a number of CPUs, with a given compute time, and maybe also possibly some restrictions about the use of the hardware. If you want to use GPUs, for example, or if you want to use only CPUs, and even the type of resources. That will depend on the configuration of the system and, well, how the options that are available in the different systems. But in general, so to say, the structure is always the same. You will have, whenever you want to run something in a supercomputer, please remember that you have a file where you indicate what you want to run. On the upper part of this file, you will indicate the sbatch directives to tell the scheduler which resources you want to use and how you want to use the system. And what comes afterwards, you can take a look at the run MPI, run OMP files. Maybe Okba, if you can maybe go to one of these files, maybe the run _ omp.slurm. As you are sharing the screen, could it be possible to do this? That you go, yeah, exactly, there you go. So there is, this is an example. So if you take a look at this file, you see that there is an upper part, and it begins with the line with the hashtag !bin bash. This is a standard line that defines a script in Linux. Everything that you see there, actually, in this file, if you remove the sbatch directives, you could even execute it in a terminal. Or let's say, maybe Okba, would it be possible to run this file directly in the terminal? Just to give you an indication, this is basic Linux. But could you just execute it with a terminal? You see the content? Yeah, exactly. With that. Yeah. So, and then, for example, you can do /run run omp slurm. That's something that you can try, because this is a very simple task. So you cannot do this, for example, if you are wanting to execute, let's say, a GROMACS simulation, or you want to use VASP, or a really large, essentially a very much time-consuming task. But when you are running a very small hello example, or just showing the environment, and just printing something out in the screen, printing the date. So you can actually do this in a very much interactive way. And it's good that you understand in the way of that Linux works, and the way that you work with with the supercomputer. A very simple script you can execute in the terminal. But when you want to, let's say, execute a blood flow simulation and which is some of the tasks that you may do in the next days, then this is when you are requiring to put the right commands, let's say the right sbatch directives to indicate we have these directives, this indication for the total time of the job and the hardware needed, and then you will submit them with sbatch and then the name of the file script. Well, I don't know why it is hanging too much there.
It's because of the resources.
Okay, maybe then it's the resource. Yeah, I believe it's not directly then to execute the command, but let's say this is a possibility actually that you execute it directly. Could you do show again the content of the file, Opa?
Yeah, sure.
Thank you. Yes. So if you take a look at the different indications, you have, for example, some interesting names. When you see the sbatch directives, you see sbatch, and there is a job name, which is hello OMP. This is a simple identifier for this job. And then the next one is -- QoS. And QoS, for example, is defining a so-called quality of service. So this implies some restrictive environment within the supercomputer so that you are running training tasks. You are running in this quality of service that the system administrators have configured and has, let's say, some limitations, probably that you cannot run for more than 30 minutes. You cannot use more than a couple nodes in the system. So to say, for example, as you are a training user, it's very likely that the system administrators have restricted you from using the whole supercomputer and submitting a job that will use the whole Mare Nostrum. That would be undesirable for a course. So that's why you have this kind of quality of service, and which is a description of some restrictions in the system so that your job wouldn't be using a lot of resources or be running for a really long amount of time, so to say. If you continue a bit down, then there is another indication about the number of tasks. N tasks equals 1. And over there, this indicates that you would be using one process. That's a very important concept. Let's say a bit more complicated because it goes a bit into the parallel part, because you are there are different ways of running in parallel, and in this case what we are doing for this example is to run with OpenMP, which means we are running with threads, so that we have one program, and inside this program we have many threads. So the description is one task, and the line below indicates the number of CPUs per task. So we have one task that is running 8 threads, which this is what it means here. And below you have also the maximum execution time for your job. Please note that we have here 5 minutes. The time is described as 00 hours, 05 minutes, 00 seconds. This is really important to understand that when you have such a job, the amount of time is something that is restricted for the system. This is very strict, so that the system gives you 5 minutes to execute the job. If you need 6 minutes to execute the job, you cannot beg to the system, please give me 1 more minute, because the system will not understand it, will say, well, you have said you needed 5 minutes. In these 5 minutes, your job should be executed. If it is not executed, that's your problem. you don't have more time because there are many other jobs from many other users that need to be executed at the same time, and we have to optimize the resources. You said 5 minutes, you get 5 minutes. No more than that. You may get less if you don't need the 5 minutes, and that would be fine. But you need to put always enough time so that your job can be executed on time. That's
so,
a very
Carlos,
important.
Carlos, just a naive question. So, if I never use, let's say, some program or some, I don't know how much time. So, what is the rationale actually of estimating time and resources like the number of tasks and the threads that you need to run the job? How do you rationalize that if you don't have prior knowledge of that program?
When you don't have prior knowledge, you need to overestimate. That's the only solution that you have. Okay. And additionally to overestimating means also benchmarking. So it's two actions together. You need to put a really large execution time so that you are completely sure that within this time your job is executed. Mm-hmm. And secondly, when you do that first execution, you need to also measure the time that it actually took. And with this, you need to learn that, let's put an example. You have a task that you execute in your laptop. In your laptop, it takes 1 day, 24 hours. Yes. You want to go to a supercomputer because you think this can be executed faster. You have the advice to use many nodes and many CPUs, and that it will go faster. Then what you should do as a best practice is first to ask the people from the supercomputer, so to say, in order to learn how to run this program in parallel. That would be important. If you want to use Chromax, for example, or VASP, it is important that you know in advance how to run in parallel those programs, for example. That's something that you may ask or you may already know in advance. But once you know this, how to run in parallel, how to use the software, then you should think, okay, in my computer, running sequentially without any parallelization, it takes 24 hours. Let's assume that the computer will be faster, and but just in case, I am not sure if I may do something wrong. So you would simply choose to put, instead of 24 hours as maximum time, even put 30 hours when you run it for the first time in the supercomputer. That's completely safe for you. Then you go to the supercomputer, you put these 30 hours, and most of all, you measure the real time. And you can do this very simply. Okba, if possible, could you go to the sran command over there? And when you are over there, you can just simply put time, and then after that, the same command. There we have a very, very simple time measurement for your job. Only using the command time, you know how long it takes. Another practice is, as Okba has put in this script already, this is also another good practice, to put date command when it begins and date after the command, so that you know a timestamp when it began and a timestamp when it ended. Then you do the subtraction, and you can just simply know the how long it took actually. And that's the information that you should take home somehow. Let's say you have executed the command, and instead of 24 hours, it took 4 hours actually. From 24, you went to 4 hours. That means that you can adjust the time in the next execution. If you know a similar system, then you can put 4 hours for the execution time plus some additional, let's say, some added time just in case you have some oscillation in the compute times. I hope I have answered somehow.
Yes, yes, that was extremely informative and very, very clear. I really appreciate it. I think I'm starting to wrap my head around it. Thank you so much.
Yes, you're welcome. I want to comment also that there are several oscillations when you are executing one task. Please be very careful if you are reading and writing many files, because when you are doing these tasks, you are very likely having some difference in the execution time because of the file system. So it is very, very likely that a program with an intense file reading and file writing will have some difference in terms of minutes within 1 hour. This is even possible, that you run a program, it takes 1 hour, then you run it again, and then it takes 1 hour and 5 minutes, and then you run it again, and it takes 58 minutes. It can oscillate very easily. That's why we always recommend to put a given time that you know it's, let's say, an average time that it will run, plus some additional time that allows some, well, for some issues in the reading or writing of files. It is very wise to add, let's say, 1 hour in this case, just to avoid any problems with the reading and writing. And with that, you are kind of sure that everything will be executed within the time and that your execution is not going to be cut by the system because of this allocation. And well, that's a bit it, I think. And in terms of best practice, yes, please.
Yes, just I am stuck in the same place now. When you give me the what I can say, the information about the copying my -r file, now it's fine. So how can I, what I can say, download it to my, what I can say, PC or my folder? How can I do it?
You mean downloading? I haven't heard. I don't know if I.
No, 1 minute. I will text you here. Here. So right now I am here. So now I am. It is not showing any issues. So what should I do?
You need to execute the scp command from your local computer to MyNostrum, just as we said with the cheat sheet exercise, if you remember.
So for scp, I should do what? scp?
If you open a local terminal on your personal computer and you do scp space, so if you add a -r if it is a directory, and then you need to put your login just like that here. Here, just like in the bottom.
So I should copy this all, put in my new terminal, and that's it.
Well, you need to adjust your username, and you need to adjust also the path to your file or your directory.
Okay.
And
so when I log into new terminal, I need to put these two red highlighted what I can say commands, and then it will be fine.
Yeah, it should be fine. But still, I insist on the login, and also after the 2 points, you need to add the path to the file you want to download.
Okay.
Okay.
And with this I can download all into my PC or my directory.
Yeah, you can download it to your personal directory.
Okay. Thank you.
So one last comment. I will ask you to, if you want to have access to the slides, I think either I can share them here on Zoom and you can download them, but I've never done this, or you can either email me and I will send you, I will answer you with the PDF file attached. So my email is written here. You can note it, and I will try to do better. If the conversation closes, I'm afraid that you will lose the file. So the best thing is that you can email me and I will send it back to you by email.
Is there any particular Slurm resource that you would recommend, like some tutorials or something that you get a little bit deeper into understanding it?
Well, it depends. It depends on the level of knowledge you have on Slurm, for example. So this is the thing that I have presented to you here is pretty basic. You are not doing any fancy things.
Yes.
You can, once you have mastered this kind of operations, you can start, you know, by moving your data from one location to another before running your application. And then it depends of the application actually you will be using later on.
Okay.
Some applications are mainly serial, some other are like MPI, some other are OpenMP. So it really depends of
So
your
I was
usage.
thinking just something that can give me a stronger foundation. I mean, it's basic, like at this level, but that allow me to.
They're all good. There are a lot of tutorials on Google. Just type in Slurm tutorial and you will find many documentation.
Yeah. Okay. Okay. Cool.
Maybe just as a comment, the scripts that are shown here can be also a basis for the next days of the course. You may find also similar scripts that may be provided, for example, by Andrea Townsend Nicholson or by Gabor Zabowski in the next days. So you will see some different examples. It is important that if you take a look at these small examples with MPI, OpenMP that were shown in this session, you will be able to understand better the more complex examples from the next sessions. Just take it as a reference and even try to play with them. And later on, you will be able to just adapt to the more complex examples in a very easy way, a natural way. They won't be, you won't have only, you will have only the difficulty of understanding the scientific part, but at least this session is to avoid any kind of computational issues. And well, as you have seen, in fact, we have given this course with the sponsorship of CompBiomed. So now you have seen the comp part, and the biomed will be mostly in the next days, so to say. So I hope we hope that you are ready for the next challenges in the next days. So just be welcome to ask any questions or so. But we hope that you get a good introduction to understand how to work with the supercomputer.
Thank you all.
Okay, Opa, maybe close the session already. Is it okay? Or
yeah, let's close the session.
Yes.
I hope you guys had a good time learning about Linux and Slurm. I will send you the slides as I said by email once you have emailed me, and yeah, good luck for the rest of the training. Goodbye, everyone.
Thank you.
Thank you.